Determine the coordinates of the orthocenter for a triangle with vertices -1, 3, 2, -1, and 0, 0. Okay, let us begin. So here, let's try to understand the problem graphically first. For this, we're going to consider a triangle with vertices A, B, and C. So the coordinates of the vertices are given to us. Our goal will be to determine the coordinates of the orthocenter. Let's try to understand the orthocenter. Now from the point A, we're going to draw a perpendicular on the line BC. Let's say the perpendicular meets the line B, the side BC at D. So we have here AD, that is going to be the perpendicular on BC. Similarly, we're going to drop another perpendicular from the point B on the side CA and another perpendicular from the vertex C on the side AB. So here we have BE, that is going to be the perpendicular on AC, and CF is going to be the perpendicular on AB. Now clearly, these three perpendiculars are going to meet at a common point, and let's call this the common point O, and this common point O is referred to as the orthocenter of the triangle ABC. So our goal will be to determine the coordinates of the point O. Now how shall we do that? In order to find out the coordinates of point A, we will need two equations. So what we can do, we can find out the equation of the altitude AD on BE, and once we have the equation of those two altitudes, we can solve those two equations to obtain the point of intersection, which is going to be O. Or we can take AD and CF. So we need any two altitudes at a time. Taking any two altitudes at a time, solve those two equations. That's going to give us the coordinates of the orthocenter O. Okay, so that means we'll need to find out the equation of the altitude. Let us begin by first finding out the equation of the altitude AD. Now to find out the equation of the altitude AD, we are going to use the point slope form. So here, as we can see, that the altitude AD already passes through the point A. What we need is the slope of AD. To find out the slope of AD, first we will find out the slope of BC. Now that we can easily do, slope of the line BC, or you can say the side BC, that is going to be equals to, what we need is the difference of the y coordinate. So we take 0 minus -1 divided by the difference of the x coordinates. So we have 0 minus 2. So 0 minus -1, that's going to be +1. 0 minus 2, that's -2. So the slope of the side BC of the triangle ABC comes out to be -half. And since we know that since the line AD is perpendicular to the line BC, this implies that the product of the slope of the line AD and the slope of BC, the product is going to be equals to -1, which means that slope of the line AD, so that comes out to be equals to -1 over the slope of the line BC. So we have already obtained slope of BC, that's -1/2. So that means slope of AD comes out to be +2. So now we have the slope of the altitude AD. We are ready to find out the equation of AD. We can use the point slope form. So here we need y minus y1 equals to the slope m times x minus x1. So for simplicity, let us suppose that x1, y1 corresponds to the coordinate of point A, and slope, that is 2. So that means we have y minus y1. So y1, that is 3, equals to the slope 2 multiplied to x minus x1. So x1 here is -1, so we get x plus 1. We get y minus 3 equals to 2 times x added to 2. So let's rearrange the terms. We're going to get 2x minus y plus 5 equals to 0. So here we have successfully obtained the equation of the altitude AD. So similarly, we can obtain the equation of the altitude BE. So let's do that. First, we begin by obtaining the slope of CA. Now what we need is the difference of the y coordinate. So we have 0 minus 3 divided by the difference of the x coordinate. So that's 0 minus -1. So we get -3. That is going to be the slope of CA. So if we have the slope of CA, then this implies that the slope of the altitude BE, that is going to be equals to -1 over the slope of CA. So we get 1 over 3. So now we have the equation of BE. Since BE passes through the point 2, -1, we have the slope of BE. Its equation is going to be y minus y1. y1 is going to be the y coordinate of B. So that's y plus 1 equals to 1 over 3 the slope multiplied to x minus the x coordinate of point B. So that's 2. So we get 3y plus 3. We're multiplying throughout with 3. That's going to be equals to x minus 2. So we get x minus 3y minus 5 equals to 0. So we have obtained the equation of the second altitude BE, x minus 3y minus 5 equals to 0. So let's take equation 1 and equation 2, and then we are going to solve for the value of x and y. So we'll first consider equation number 1 and multiply each terms with 3. So 3 times 2x is going to give us 6x minus 3 times y, that gives us 3y, plus 3 times 5, that's 15, that's equals to 0. We keep the second equation as it is. So here we have x minus 3y minus 5 equals to 0. So what we'll do, we're going to subtract the two equations. So that means 6x minus x, that's going to give us 5x. Negative 3y minus negative 3y, that becomes 0. So that cancels out. And we have positive 15 minus negative 5, but that gives us 20 equals to 0. So solving for x, we get x equals to negative 4. So now we can substitute x equals to negative 4 either in equation 1 or 2 to get the corresponding y value. So y comes out to be equals to negative 3. So we have obtained the coordinates of the orthocenter. So we can say thus the coordinates of the antecenter are going to be negative 4, negative 3. So you can verify that by considering the equation of the third altitude CF, which we have excluded here. So you can take as the equation CF and PE, and when you solve for those two equations, you should get the orthocenter equals to negative 4, negative 3.